in the memory management topic in background, we'll see we'll understand what is memory and how the program is loaded, what are the different stages in which the program is loaded into the memory, and something about like all of you know already that any program which is stored in memory has its own area. Okay, it has its own area, and each program has its own area, correct? So a program has its own stack, its own heap, and the data part. So all this is for a program P1. Fine. There is a starting address and an end address for a program P1. And any program, that is this program P1, can access only the instructions present in this particular limit. Okay. If it wants to access some other program's area, okay, operating system must give permission for P1 to access other programs area, that is shared memory, and that is in interprocess communication you had seen. Okay, part of the memory can be shared. Fine. Or a library file has to be shared. There is library file which is stored in primary memory, stdio.h file is there. Okay, P1 wants to access this file. Okay, then this share permission has to be given by operating system so that the program can share this part of the file. Okay, other than this, a program has its own area, and the program can access only the limited area of the memory. Okay, so any program to be executed must be brought to the memory, and each program has its own memory space. Okay, protection of memory must be done because P1 must be allowed to access only this particular area, correct? Only this particular area P1 must be allowed to access, and hence the checking should be done before the accessing of any memory instruction. It must be checked whether it is this program's area itself. Okay, checking will be done, and then access of the instruction or access of the data is done by the processor. Okay, we'll see how the checking is done in the next few minutes. Okay, so protection of memory for accessing the data must be done so that, yes, the correct instruction of the particular program itself is taken. Fine. Okay, so user program goes through several steps before it is executed. So you would have heard the terms loading and linking of programs. Okay, so program is being executed. Now C program has to be executed. C program is compiled first. Okay, it is compiled, and suppose it is calling some files. Okay, it is calling some files which is built, which is written by me. Okay, by the user. It has other than library files, it is calling some files. Then those files should be linked to the program. Okay, those files should be linked to the program, and this program, after linking, compiled and linked program, must be loaded to the memory. It is a different it doesn't contain only the program, it contains also the other linked files. Okay, and it has to be loaded to the memory. Okay, and after loading this executable file to the memory, the execution of this file takes place. Okay, during execution there can be dynamic memory allocation. Okay, dynamic linking of files. Okay, all this dynamic loading of files. Okay, all this takes place during the execution. Dynamic loading and dynamic linking. Okay, now we'll see a diagram with respect to this. So multiple steps during the program, before the program execution. Okay, so first the program is compiled, source program is compiled. This is called the compile time. And an object module is produced. You get .o files. Okay, within that, you will not know that. Okay, .o files are created. Object modules are created. Okay, and after this program is compiled, you can see that other modules or other packages, okay, or what to say, okay, now a large project is divided into different modules. Okay, to make it a complete module, if there are some parts of the project, okay, different modules of the project or different functions are written in separate packages, separate files, okay, they have to be linked to this particular program. Okay, and that is done by the linkage editor. So here there is the load time. After it is linked, it is given to the load module. What the load module does is it loads it to the memory. Okay, loads it to the a particular part of the primary memory, and this is the executable file. This is the executable file which is obtained. Okay, during the execution there can be dynamic loading of files and dynamic linking. Okay, so loading is nothing but bringing it to the bringing the program to the primary memory. Okay, linking is it is already in memory and a part of the program. So dynamic linking is during runtime, during the execution, the files are called. Okay, the files are called. So that is the dynamic linking. Okay, and this is the execution time. Right. So after this, the execution starts, and the program is in the in a particular location in primary memory. Okay, so that is about the user program before the execution takes place. Okay, compilation and the linking with other files of the user. Okay, if it is there, and then the program is loaded into memory. Fine, and then execution takes place. Okay, now we'll see two terms which is always used throughout when you say memory. There is this word, that is logical address and physical address, and logical address space and physical address space. Okay, so what you know is the physical address space, that is RAM memory, which is physically present. Memory which is physically present is RAM, what we see, the primary memory. Okay, other than secondary memory I'm talking. Now we are talking only about the primary memory. So RAM memory, that is the primary memory, is the physical memory which physically exists. Okay, it has its own address space. So this is the address space of primary memory. Now what is logical memory? Logical memory is also called as virtual memory. Okay, and by the term itself you can see it is virtual. The memory does not exist. It is an illusion. Okay, so why is that memory required? Why is that memory required? Now, in when the program is executed, suppose there is secondary memory. Okay, so there is secondary memory in which the program is there. Okay, the whole program is there, and suppose it is 1000 kilobytes. Okay, 1000 kilobytes, and memory is only of 500 kilobytes. Okay, or 512. I have just taken as 500 for easier understanding. Okay, memory is only of 500 kilobytes. This 1000 kilobytes, the whole program cannot be stored in memory. That much space is not there. Okay, so we imagine that a memory is there, a virtual memory is there. Not we means not the user, the processor here, CPU, assumes that there is a virtual memory and addresses are generated by CPU for this virtual memory. Okay, so CPU assumes that the whole program is continuously stored, and the address from okay, so 0 to 1000 KB, okay, 1000 kilobytes of data is continuously stored in virtual memory. It is an imaginary memory which the processor assumes it is there. Okay, but only what happens now, as this is on 1000 kilobytes, only a part of this memory, this program, whichever is needed, is stored in physical memory. Suppose, okay, so on the required part is only of 200 KB. Okay, now always required, and currently executing is only 200 KB. Okay, P1 program, which is the where the main function and all is there. Okay, so 200 KB is stored here out of this 1000 KB. Okay, now the processor wants to access this instructions, which is of P1 program. Okay, processor generates the addresses for this logical address space. That is, it generates the address 250 location which has to be accessed. Okay, some location which has to be accessed, and it wants to access the instruction in this location. Okay, this is the virtual memory. The address generated by the processor is for the virtual memory or the logical memory. Okay, and this address is converted into physical memory by memory management unit. We'll see what is memory management unit later. Okay, so this is the virtual memory or the logical memory. Here is the physical memory. Physical memory is the memory which actually exists, and programs are loaded in the physical memory. Okay, and logical memory is the memory where the program is assumed to be fully stored. Okay, where the program is assumed to be fully stored, and the processor assumes that the whole program is continuously stored from 0th location to 1000th location. The full program is present. Okay, and it generates addresses to this location. Might be that in memory, the program, in the primary memory, the base address, the address at which this program is stored is okay, 10. Okay, or suppose it is some location, suppose it is 250 or 300, where this data is stored. The base address is 300. Okay, from 300 location, the some 200 locations is for this particular P1 program. Okay, so this address must be converted to this physical address, and that is the task of memory management unit. Okay, so this is about the virtual memory, and we will see later again in detail about virtual memory. This is just the introduction. Okay, so logical address is the address generated by processor, and it is called as the virtual address or logical address. Okay, physical address is the address seen in memory unit or the main memory, and where the program is actually stored. Okay, logical address space is the complete address, the total space of the virtual memory is called as the logical address space or virtual address space, and physical address space is the complete storing space of the physical memory. Okay, any doubts, students? I will just show you this. Yeah, this is the memory management unit here. This is the logical address which is generated. Okay, this is the base address of the program. Program is stored somewhere here, 1400th location. Okay, and the program is stored here in primary memory. This is the logical address space, which is assumed to be there, which is actually not there. Okay, so processor wants the instructions from the 0th address. It goes on increasing. That is how much our the program is. Whatever length the program is, the total program is assumed to be stored in this logical address space. Okay, we'll see a few more introductions, and then you can ask if you have any doubt. Okay, now a memory management unit. Yes. Okay, hardware which maps. It contains hardware and also some data, okay, which is stored. Okay, so it is, you can imagine as a hardware which maps the virtual address and the physical address. It consists of some registers and all, okay, which is used for relocating, storing the base address and locating the address of in the physical memory. Okay, so it maps the virtual address to the physical address. Virtual address is the address generated by the processor. Okay, the value in relocation register is added with every logical address. We'll see that addition. Okay, now this is the hardware setup. What is there? Memory management unit. Okay, memory management unit. Something is there. What does it do? It maps the address from logical address, which is generated by the processor, to the physical address. Okay, so fine. So this is the base address, and here you have seen a term called as limit. What it is after one operating system is loaded initially, okay, at the 0th address, operating system will be stored in the primary memory, and then at a certain location, suppose this program is stored, fine, we'll take same 1400, okay, some location, the program is stored. This is the base address or the starting address where the program is stored. Okay, suppose the program is using 500 addresses, okay, 500 addresses from 1400, okay, 14,000 is the base address. Okay, so the last address is 14,009 499. Okay, 14,499. So the limit of addresses is from 14,000 to 14,499, or if I say 14,001, if I take, it is 14,000 to 500. Okay, means the total addresses is 500 addresses. So the limit is 500. Okay. Okay, so as I have taken in the example, I will take as 1400, and there is a limit of, means it is addressing 500 locations. The program P1 is using 500 locations. So the last address is 1400 and 14,499. Okay, now what is the base address value? Base address value is the starting address of the program. Okay, all this base address, the limit value, all this data will be stored in the process control block of the process. And whenever this program is loaded into the processor, this data from the process control block containing the base address where the program is stored, the limit of the program is stored in this particular registers. Okay, so there is base register and limit register. Limit has the value 500. Okay, base has the value 1400, sorry, 14,000. Okay, now the address whatever is generated by the processor, it should be greater than this 14,000 address and less than base plus limit, that is less than 14,500. Okay, so if it is within this particular memory space, then only access is given. Otherwise, a trap, that is an interrupt is sent to the operating system. Okay, an interrupt is sent to the operating system. Illegal memory access. Only this part of the memory can be accessed by the program P1. Okay, now this is for the protecting the memory. For protecting the memory, we are using this concept. Now there is CPUs, there is some address generated, okay, by the processor. This is the okay. So this is the address which is converted to the, after converting to the physical address by MMU, this address is obtained. Okay, check whether it is less than, greater than or equal to the base. If yes, then check whether it is within the limit. Okay, and that is, it is less than 14,500. If yes, then permission is given to access the part of memory. Okay, so this is for how the protection of data is done from being accessed by any other program. Okay, we'll see about the memory management unit later. Okay, now this is the address which is generated, which is converted to the physical address, and then you are checking whether it is within the limit, within that particular area. Okay, now this is the basic introduction to memory. You have seen that there should be protection given to the memory and each program has its own space. Okay, how the execution takes place step by step, what is physical address and what is logical address. Okay, logical address is imaginary, it does not exist. Okay, and there the program is assumed to be stored continuously. In physical memory, only the part of program may be stored. Fine. So this is about the logical address space and physical address space.